Well, as I told the group this morning, this is a real pleasure for me to be back here, and I say back here because this is where my mechanic career started. The same chairs you're sitting in, 21 years ago. I graduated from here, and I was working for a Chevrolet dealership at the time, and I stayed with them for about 4 years. Then I went to work as an aircraft mechanic for a couple of years. Did that, and then I went to work for Halliburton. I've been with them now for about 15 years. First went to work up in Kansas, then I went from Kansas over to the Middle East and spent a considerable amount of time in North Africa, Libya, Kuwait, all the garden spots. Nice places, they seem to be. And then I came back to the States and went to Colorado and worked up there for about 10 years. About a year and a half, almost 2 years ago, they decided to implement a computerized equipment maintenance program. We're going to get into that after I give you the sales pitch for Halliburton. I might mention that we are on a hiring freeze at the present time, but we look for that to change around here in the near future. We've got our fingers crossed. We hope that everything's bottomed out and we're starting on another incline. We haven't laid off any mechanics lately. They've been doing some other things in other parts of the business, but as far as that part, it's been pretty steady. We haven't lost any of those people. A year or so back, we cut back to the point they couldn't cut back any more mechanics. And as a mechanic, they've also furloughed mechanics over the drivers just to keep them on, and they bring them back in as a mechanic. And the pay differential there wasn't very great, so we really, our mechanic crew, we didn't lose a lot of it. I've got a video I want to show you about the world of Halliburton. It doesn't specifically pertain to hiring mechanics for Halliburton, but it gives you an overall picture of what Halliburton does, where we operate, things we do. You mentioned you're familiar with Halliburton. Anybody else, other than the sign in the hall downstairs, know what Halliburton is or what we do? What do we do? Well, that's true. We're pretty diversified now. Right? We're out of Duncan. That's where our engineering manufacturing center is. Halliburton started off as a cement company. Earl P. started cementing with horse and buggy, and I don't remember exactly here. I think the video shows that. And they started cementing casing into the well, cementing around the outside of the casing. And it went from there to what we are today, a very diversified, largest service company in the world, and we have a lot of other companies that also hire mechanics. Brown and Root, which is one of our sister company. It's probably in some respects the largest construction company in the world. They hire a considerable amount of mechanics. We also have an industrial services division that hire a lot of mechanics. So as far as the mechanic end of it is concerned, we employ a lot of mechanics, and we have been a little bit stagnant in the hiring because of the economic situation lately, but hopefully that'll change. We'll show this video, and then we're going to open it up to some discussion. We'll try to give you some answers about what you might be interested in looking at a trade. I have, other than working for Halliburton, I've worked in dealerships and some other things. I might be able to give you some insights and try to answer some of your questions along those lines. Then we'll get over into the computerized maintenance part of it. Look at that.
Every geographical sector of the globe where probing bits seek out subterranean deposits of gas and oil, one name is synonymous with the energy industry: Halliburton Services, the recognized world leader in oilfield service technology and equipment. In the early 1900s, the quest to extract and harness the force and energy below the Earth's surface had proved to be a formidable undertaking. For many, unpredictability seemed to be the only constant. With that in mind, Halliburton Services founder Earl P. Halliburton set out on a quest of his own to pioneer and develop improved methods of oil well cementing and related oil well services. Consistency and quality of service were first and foremost in Mr. Halliburton's mind. Back then, cement was mixed by hand with water in small batches. This frequently resulted in inconsistent batches that sometimes began to harden before being pumped into the well. Mr. Halliburton solved the problem with his invention of the jet mixer, a device that greatly increased the speed of the mixing process. With the jet mixer, it became possible to regulate the mixing to any desired proportion and to supply as much cement water slurry as the pumps could force into the well. Those first jobs were with hired teams and wagons. By 1920, with business rapidly expanding, Mr. Halliburton had purchased a total of 3 cementing wagons. 1921 ushered in a new era for Mr. Halliburton. He moved to Duncan, Oklahoma, and bought his first truck. By the end of 1922, the Halliburton fleet had risen to 17 trucks. News of the success of Halliburton cementing quickly spread across the country, and in 1924, the business was incorporated as Halliburton Oil Well Cementing Company. In 1926, the company began to venture abroad through the sale of cementing units to Burma and India. Further expansion of services included Canada, and then on to South America. By the end of 1934, Halliburton had cemented more than 80,000 wells in the U.S. In 1942, Halliburton added offshore services, and later that same decade performed the first commercial hydraulic fracturing treatments. Steadily, the frontiers of Halliburton's operations continued to expand to keep pace with the geological and geographical horizons of the worldwide search for power and petroleum. Scarcely 40 turbulent years went by between the birth of Earl P. Halliburton's vital idea and his death in 1957. His vision of steady growth, quality service, continued research, and customer satisfaction continues to be the driving force that has propelled Halliburton Services to the cutting edge of energy-related services and technology. Currently, Halliburton Services operates in over 60 countries with over 240 service locations. This worldwide geographic presence allows our company to be extremely competitive regarding mobilization fees, our labor costs, and country-specific operating procedures. Strategically located around the world, Halliburton field locations are designed to provide customers with equipment that's highly maintained and ready for service. Additionally, laboratory testing of chemical mixes for stimulation and cement mixes for cementing wells is readily available at the service center. The materials and equipment are available so that the service center dispatcher may receive calls for jobs and immediately dispatch the right combination to the location to fulfill the requested service. In all locations, the dispatch service is available on a 24-hour-per-day basis, and in some locations, personnel are ordered and available for round-the-clock service. Today, in most of the countries where we operate, supervisory and operating personnel are citizens of their respective countries. This trend is increasing as more and more of our people, of whatever background, acquire the necessary skills and experience demanded of Halliburton people. The very first offshore well included a Halliburton cementing truck on location aboard a barge. This was the forerunner of what is today's largest marine fleet of special-purpose service vessels around the world. This is the flagship of the Halliburton fleet, the Scandi Fjord, the first stimulation vessel engineered specifically for North Sea operations. This state-of-the-art vessel incorporates all the service capabilities Halliburton is known for. Virtually any treating requirement, regardless of volume or complexity, is attainable through precise control via the onboard computer control center. From this center, engineers monitor and direct treatments with an accuracy never before available. Another milestone came in 1949, when the first commercial hydraulic fracturing treatment was performed by Halliburton Services. In hydraulic fracturing, fluids and proppants are pumped into a potential producing formation at high pressures to literally crack open the formation. The fissures created by this treatment are kept open by a proppant, such as sand, carried in the fluid. When the pressure is removed, the proppant remains in the cracks to hold open the fissures. In North America alone, hydraulic fracturing has increased the recoverable reserves of oil and gas by about 1/3. Many fields would not be economically viable at all without fracturing, and the process is growing in importance as fields approach the end of their natural productive capabilities. The majority of hydraulic fracturing treatments around the world are performed by Halliburton Services. In the U.S. alone, Halliburton personnel have been responsible for nearly 1 million fracturing treatments. Currently, there is a growing trend toward fracturing in such areas as South America, Indonesia, North Africa, Eastern and Western Europe, and the North Sea. Throughout our history, and regardless of petroleum drilling industry cycles, Halliburton Services and affiliates have continued aggressive research programs and maintained a presence in most of the major oil and gas producing areas of the world. Designing and manufacturing high-pressure pumping and related surface and downhole equipment to withstand pressures of more than 20,000 pounds per square inch present manufacturing and quality assurance with difficulties equaled only by the space program. Since we build equipment to satisfy our own needs, our engineering design and quality of manufacturing is based on producing the most practical and dependable equipment possible, with low maintenance and longevity as the desired result. Therefore, low initial cost is not the most important factor we consider when producing quality goods and services. Halliburton Services operates 3 of the most diversified manufacturing facilities in the world, located at Duncan and Davis, Oklahoma, and Arbroath, Scotland. Within these 3 facilities are 1,350,000 square feet of floor space and nearly 2,000 employees. Their total function is to supply the tools and equipment needed to provide service to our customers. The Halliburton Manufacturing Organization has 5 functional departments: production, facilities, materials, equipment engineering, and quality assurance. The production department is made up of 5 sections: machine shop, general fabrication and assembly shop, manufacturing engineering, manufacturing software, and product scheduling. The primary function of the manufacturing engineering section is to provide engineering and technical support to every facet of manufacturing. It's their job to see that our manufacturing facility is used to its capabilities, with the capacity available to produce virtually anything requested. Manufacturing engineering has 4 specialized subgroups: process planning, numerical control programming, tool design, and manufacturing software. Our process planning group translates the designs and ideas of engineering to production steps and instructions for manufacturing, particularly the machine fabrication and assembly shops. They provide estimates of cost to manufacture new parts or projects. They also suggest and implement necessary design changes to improve quality, cost, or delivery. Numerical control programmers are responsible for programming approximately 120 computer numerically controlled machine tools. A large percentage of our machine tools are computer numerically controlled. They're capable of higher degrees of complexity and are more flexible. This flexibility allows the shop to respond rapidly while assuring the quality and repeatability of the process. Our tool design group provides tooling for cost-effective production. This includes the design of jigs, fixtures, and special machines to facilitate the manufacturing of Halliburton products. Manufacturing software supplies computer support for manufacturing applications such as writing, installing, and maintaining the computer-aided numerical control programming systems and specialized computer support. We have complete fabrication and assembly facilities in the Duncan and Davis manufacturing plants. Our sheet metal and welding shops produce everything from 1-inch stainless steel flow meter rotors to this 53-foot-long mountain mover frac sand trailer. Our truck shop starts with a purchased truck chassis and builds our rolling equipment, trucks, trailers, and skids from the ground up. The assembly areas build up all of our sub-assemblies, valves, tools, and pumps. Nearly all parts and assemblies are treated with some type of surface finish before they leave our plant. We protect parts with various paints and specialized coatings that are applied by spraying or dipping. Plating is another process provided to most of our products. We have the capability to plate electroless nickel, zinc clear chromate, zinc bronze chromate, iridite, and manganese phosphate. We have complete heat treat facilities in our plants which are capable of processing up to 1.5 million pounds of steel a month. Engineering and quality control assistance are provided by our metallurgy department and metals lab. Our tempering furnaces are capable of reaching 1,400 degrees Fahrenheit. If needed, our underground furnaces are capable of reaching 2,000 degrees Fahrenheit. Halliburton's warehousing and distribution systems are among the finest in the industry. Personnel utilize state-of-the-art warehousing technology, including barcoding equipment, computerized dock-to-stock tracking systems, and computerized order servicing and distribution systems. Fully automated material storage retrieval systems keep pace with the demand for product readiness. Halliburton Services has maintained its leadership position by providing a wide range of sophisticated services and products that were designed and manufactured at our facilities. More than ever, our customers expect and demand quality in our products and services. To achieve this level of quality requires dedication and continuing commitment to quality assurance. Each Halliburton product is reviewed, appraised, tested, and monitored to assure our customers of product quality and service that meets or exceeds their specific requirements. Halliburton Services manufacturing quality programs follow an extensive audit of manufacturing and verification standards. Lloyd's Register awarded its coveted and first Quality Assurance Certificate of Approval to an oil field service operation to Halliburton Services. Named Laboratory of the Year in 1981 by Industrial Research and Development magazine, Halliburton Services' main research center is the largest of its kind in the oil field service industry. Located in Duncan, Oklahoma, this 230,000 square foot facility was constructed in 1980. Other research labs, shops, pressure testing facilities, and test wells are located strategically nearby. We have more than 45 field laboratories outside the United States and operate a European research center in Holland. Halliburton Services Research has one overriding purpose: to provide answers that can improve industry operations. Those answers come from projects as routine as determining the compatibility of a fluid with a formation in a specific well, and from projects as broad as an ongoing study that's investigating materials and techniques applied to annular gas leakage problems. Approximately 4,000 different projects are underway at any given time in Halliburton Research Center laboratories. These projects answer questions from sources as varied as single well operators, major company research departments, Halliburton field personnel, and the research center itself. In addition to developing practical answers for specific questions, Halliburton Research has increased its emphasis on basic research. Major areas being investigated include research in hostile environments, such as high pressures, high temperatures, deep holes, geothermal wells, aggressive chemicals, and horizontal well completions. Halliburton's reservoir research activities encompass two broad areas: work to develop answers to specific questions brought to the research center by Halliburton customers and employees, and experiments and studies to expand the industry's knowledge of reservoir science. Basic reservoir work is performed because it often holds the key to improving our answers to completion, stimulation, sand control, and enhanced oil recovery questions. Determining basic rock properties has been a key area of investigation for several years. Using some of the most advanced facilities available, Halliburton is determining and evaluating the factors involved in containing a created fracture within a given formation. Frequently, the data developed forms a solid basis for effective stimulation treatment. Answers developed by Halliburton researchers provide technical support for a field service operation that has pumped more oil field cement than all other service companies combined. The cementing services supported by Halliburton Research include primary oil and gas well cementing, cementing liners, remedial cementing, water shutoff, setting cement plugs, cementing waste disposal wells, grouting of mines and subsurface irregularities, cementing geothermal wells, grouting of offshore drilling structures, cement entrainment of toxic waste, cementing solution mining wells, stopping lost circulation, and repairing blowouts. Halliburton's cementing research capabilities embrace every phase of cementing operations, from cement products and chemicals through cementing procedures to equipment used in cementing operations. One reason for Halliburton's leadership in oilfield cementing is the ability to provide answers based on large-scale tests that simulate actual cementing operations. With this capability, we can test new materials and equipment under much more realistic conditions than small-scale tests allow. Halliburton's leadership in stimulation technology dates back to 1933, when its acidizing research program began. Today, Halliburton Research is involved in every aspect of stimulation services, from developing new techniques, fluids, additives, and equipment, to answering questions about treatments for specific wells. Product development and improvement activities center around hydraulic fracturing, fracture acidizing, matrix acidizing, and special service chemicals for well cleanup and for preventing scale and paraffin problems. Incorporated in that work are projects for developing additives to prevent corrosion, chemicals to remove and inhibit scale and paraffin deposits, materials to prevent and break emulsions, acid retarders, acids, fracturing gels, breakers, fluid loss additives, and proppants. To provide the best possible answers, the Halliburton Research Stimulation Section is equipped with a vast array of sophisticated instruments, including this scanning electron microscope, permeability change flow meters, X-ray diffraction, rheometric viscometer, viscometers, recirculation flow loop, acid kinetics measurement equipment, large-scale fluid flow loop, and computers and software to model real-life situations for laboratory experimentation. To develop answers for one of the industry's most difficult problems, controlling sand production, Halliburton Research has invested substantially in people and equipment. The Sand Control Services Section's work involves developing effective new sand control methods and products, as well as evaluating treatment designs under simulated downhole conditions. Halliburton is clearly the industry leader in development and production of pumping and materials handling equipment. In fact, the vast majority of pumping and bulk handling equipment used by Halliburton field operations was designed and engineered by Halliburton. Charged with meeting the energy industry's needs for the future, Halliburton engineers designed and built the ARC system, or Automated Remote Control System. This totally new concept in fracturing equipment technology is already changing the definition of treatment control. The ARC system combines the latest equipment and real-time data acquisition techniques with the most advanced pumping and blending equipment for the first totally automatic remote-controlled stimulation system. The Tech Command Center is the nerve center of the ARC system. All data is funneled through the Tech Command Center's mini-computer-based system for real-time calculations, display, and storage. The Tech Command Center can control all of the equipment. Every second it monitors over 1,200 surface parameters, rates, densities, material inventories, and equipment status. It continuously calculates wellbore conditions such as friction, hydrostatic pressures, as well as bottom hole parameters, while at the same time measures rates, pressures, and proppant concentrations. The Tech Command Center is designed to enable Halliburton personnel to effectively interact with customers to control or, if needed, redesign the job based on real-time data utilizing color-enhanced displays. Halliburton Research has an ongoing program to constantly improve the reliability and efficiency of Halliburton surface equipment. In many cases, Halliburton equipment developments have revolutionized the way services are provided. For example, Halliburton developed the systems that made bulk cementing possible, and the Halliburton developed HT400 service pump has set standards for reliability that all other service pumps are judged by. Further innovation and design of the HT400 has resulted in the development of the Halliburton horizontal quintuplex pump. This unit is specifically designed for use with powertrains in the 1,000 to 1,650 brake horsepower range. Additionally, development work is underway to produce new generations of higher horsepower pumps for the future, like this Halliburton HT2000 triplex pump, capable of developing 2,000 plus hydraulic horsepower. The development of the HT1000 and HT3000 intensifier pumps make long, high-pressure stimulation treatments almost routine. These units use high-volume, low-pressure fluid from HT400 pumps to pump low-volume, high-pressure treating fluids, thereby intensifying the treating pressure. Halliburton intensifiers have been designed to withstand the rigorous demands imposed by the increasing number of large and prolonged stimulation treatments and other deep pumping applications which up to now were considered impractical. In addition, the development of highly portable skid-mounted equipment has made it possible to provide high-volume, high-pressure services to offshore and remote locations. Halliburton Research is responsible for the design of downhole tools used in providing formation testing, cementing, stimulation, sand control, and enhanced oil recovery services. Tools developed by Halliburton Research isolate zones, spot fluids, stage operations, control and measure fluids, record temperature and pressure data, establish condition of perforations, and aid in reversing out fluids after a service procedure. Prototype tools and design modifications can be tested in one of 3 Halliburton test wells. Virtually any casing size can be used in the wells, and pressures can be created in the well to reflect actual operating conditions. In addition, Halliburton has developed a deep well simulator that allows tools to be tested under extreme pressures and temperatures. Continuing advances in electronics benefit the entire scope of services offered by Halliburton. Thoroughly experienced in the specialized requirements of the petroleum industry, Halliburton's research in electronics includes monitoring, sensing, and computer systems that place more real-time information in front of both producers and Halliburton specialists. This information can be a valuable asset in making critical decisions that are vital to the successful execution of cementing, fracturing, and other well completion and improvement procedures. A successful cementing job depends largely on consistent and precise density control of the cement slurry as it is being mixed. Halliburton Services has developed the industry's first automated recirculating cement mixing system. The automatic density control system, incorporated with our time-proven recirculating mixer system, provides accurate control for all cement blends and mixing rates required for today's downhole conditions. The ADC RCM automated system is programmed at an operator interface keypad. Here, the operator enters the density and mixing rate information for the specific blend design. At any time during the mixing process, the operator can instantaneously change the mixing rate without affecting the density. In addition, any necessary adjustments that need to be made during the job can be programmed from the keypad, including preloading all information for the next slurry. By automatically uploading the next slurry requirements at the exact time, precise quality control is automatically achieved. To allow for job performance to be strip chart recorded or downloaded to computer disk for future evaluation and design, the ADC system is designed to be compatible with Halliburton's CompuPack system. The Halliburton CompuPack is a portable data acquisition system used to collect data on the well site for cementing, well stimulation, and well testing jobs. The CompuPack system can be powered by car battery or standard AC power sources and is useful in applications such as job design, data analysis, closed chamber testing, automatic proppant control on stimulation jobs, and data recording on cement jobs. Customer demand for post-job data increases daily, and with this equipment, we're able to meet much of the demand on-site without the need for processing on a mainframe computer. In the early 90s, it is expected that we will routinely control well completion operations at remote sites by communication over a satellite network. In this way, experts in a central location could control and influence job operation in multiple locations simultaneously. This world map shows the present Halliburton computer network. Our locations around the world have online access to our mainframe computer. Our research center has developed and is maintaining over 60 engineering computer programs to assist in job design. Using the computer and communications network, our field operations personnel use these programs more than 7,500 times monthly. Historically, when critical well situations or blowouts develop, the first service company for the job has been Halliburton. From Sumatra to King Christian Island, our team of experts have responded. At Halliburton, we know that critical situations demand quick response time. That means portability, reliability, proven pumping power, effective control systems, and safe operations. Our experience, plus the integration of advanced technology and equipment, help us provide the strongest support operations available to the industry. The completion of horizontal wells has surfaced as the new challenge of the future. The problems of testing, cementing, and stimulation are today being solved by Halliburton scientists and engineers. By developing the tools, techniques, and materials necessary to meet the challenge of horizontal completions, Halliburton Services has emerged as the industry leader. Halliburton Services conducted the petroleum industry's first symposiums on horizontal completions in Duncan, Oklahoma, at the Halliburton Energy Institute. Oil people from around the world have attended these sessions to learn more about Halliburton's technology, experience, and research in this field. Many of Halliburton's scientists and engineers are guest instructors at the Halliburton Energy Institute training facility in Duncan. Halliburton Services continues to devote a sizable amount of time, effort, and money toward keeping our employees and customers up to date technically. Comprehensive courses such as modern completion practices, cementing technology, and stimulation design have been developed to meet the specific needs of the oil industry. Many oil operators, including foreign national oil companies, specify one or more of these courses as part of their internal training program. Participants from nearly 70 countries have traveled to Duncan to take advantage of courses offered at our training facility. In addition to comfortable classrooms with computer-controlled audiovisual systems, the Institute also has living quarters, a dining service, and recreational facilities designed to provide a relaxed atmosphere that encourages learning and the exchange of ideas. Students have unlimited opportunity for informal discussions with other participants to share experiences and information. Past participants have remarked that this interaction can be almost as valuable as the formal instruction. Halliburton recognizes the importance of effective training. It's our continuing commitment to provide the training and technology necessary to make the most of every well. We are a service company, and that means providing the best service, equipment, and technology from exceptional people. Earl P. Halliburton's vision of steady growth, quality service, continued research, and customer satisfaction is now and will always be the driving force behind Halliburton Services. Halliburton Services, the recognized world leader in the oil field service industry.
Somebody asleep now? You might be sitting there asking yourself, what does all this have to do with me as a mechanic? Well, you might notice that all that equipment that we're hauling out to the job is all truck mounted. And as a Halliburton mechanic, you work on everything from bumper to bumper on that unit. I told the morning group, I said, except the fluid end on the pumps which the operators work on. Really, that's not true either. Most Halliburton mechanics learn to repack the pumps, because if they go to an overseas location, they're probably expected to act as an instructor, teaching other people how to do this. Basically, a Halliburton mechanic can work on just about every piece of equipment, that rolling equipment you saw in that film. As a Halliburton mechanic, you'd probably be expected to not, how to put this exactly, you wouldn't be home all the time. It's a very type of, if you're looking for an 8 to 5 job, it wouldn't be the place to go to look for employment. Particularly if you get into the overseas market. And this is probably be working on a 28-28 schedule and off on remote locations and things of this nature. That kind of thing really interested me when I got out of school, and it took me a number of years to make up my mind that's what I wanted to do, but once I did, I really enjoyed the travel. I spent a great deal of time in the Middle East and North Africa, Europe, and for the last 8 or 9 years up in Colorado chasing that equipment up and down the highway. Spent 1 year in Trinidad doing a lot of coal gas fracking in Trinidad. They send a mechanic down there on about a month at a time or better. We'd either be living out of our truck or in motel rooms. They usually supply the mechanics that go out on these remote locations or out in the field. Be driving a large service truck of some type, either a welder, pretty good supply of parts, things like this. And well, you can only fix so much out in the field. If it gets bad enough, you're going to have to take it back to the shop. But it's real challenging. Halliburton, for me, that was the type of thing I was looking for. I tried working in a truck shop where they brought the job in. I did this one. I took that one out and brought something else in. I really didn't care for that too much. This is the kind of thing I was looking for. There's a lot of responsibility put on the mechanics that work for Halliburton. Most of them, in fact, all of them, after a period of time, have what they call now the CDL license. They're required to get that. Of course, it wouldn't work for Halliburton. You would be required to have that maybe immediately, but it would be a requirement that you would have to get that eventually. I wouldn't say that I could operate every piece of equipment that you showed on that video, but I could operate a large percentage of it. And as a Halliburton mechanic, over a period of time, you can learn to do that, simply because a lot of times they come in the shop, and they run out of personnel. They got a cement job that comes in, they're out of people. I would grab a Halliburton mechanic and take him out there and have him operate one of those pieces of equipment. Not only that, Halliburton mechanics, as a rule, I said they have a lot of responsibility on them, and along the lines of teaching just service employees will hire basically truck drivers, little workers, and they don't know a piece of Halliburton equipment from any other piece of equipment, and we start them out as drivers, and the mechanics kind of end up, designed that way necessarily, but they end up as instructors teaching people pump packing, pump procedures, operating the equipment, things like this. And you'll find that a lot of the field personnel, when they're starting out, will be going to the mechanics and asking them questions on how does this work, what do I do with this, and so on and so forth. When you're out on location working on some of this equipment, most of the time we just have one mechanic out there, but all the service personnel that are out there on that job site would be lending a hand, so to speak. If we needed a hand to lift a piece of heavy equipment or screw this together and do that. It's kind of all, it's a one-for-all type deal. Some of those jobs that they run easily run $250,000 ticket to the company that they're doing that job for. And I have a Halliburton mechanic out there sitting there in a pickup, and you might sit there all day long, and all of a sudden a hydraulic pump goes down, and they're in the middle of one of those jobs, and they've got only a certain amount of time to get that fixed and get pumping again before they could actually hinder the well or damage something, or the job would have to be aborted altogether. So there's quite a bit of pressure there that I think it's really a challenge to be able to do that type of troubleshooting and work on the equipment. In the shops, we don't do much overhaul as far as in-frames or engine overhaul. If you go to work over in some of the foreign countries, you might get into that simply because we will build them there because we can't parts shipped in, or we can't get a rebuilt engine in, or time factor or something like that. But normally, we'll do exchanges on engines. We don't actually get into the engine rebuild. I probably haven't looked at a test pump or a test stand to run a pump since I got out of school here. 21 years ago was the last time I saw one. I would probably remember how to bolt it up to the stand. But we do more troubleshooting when we do that type of work. If we have something, a pump go down, we'll yank it off, either have an exchange to put on, or run it down the Cummins and have it go through the pump and get the pump back. One of the questions asked this morning was, what about schooling? Halliburton maintains, or tries to maintain a good continual education for the people, mechanics included. They have a hydraulic school that everybody is pretty much required to go through, and they'll bring it around and do an update on that at least every other year. They've got a trailer that can haul around from location to location here in the States, and it can actually simulate different types of problems, hydraulic problems. The instructor will teach basic hydraulics and advanced hydraulics course. And as you can tell from the equipment, we've got a lot of hydraulics, a lot of automated hydraulics. That TCC, that Technical Command Center that we showed in the film, they can actually hook up as many as I think a dozen, or could be more of those frac units. Most of those have two big V12s on them, 2 pumps per trailer unit. They can hook those things up and actually run the throttle, monitor all the engine RPMs, temperatures, oil pressures, all that right from that one control center. And the job is all run by just a couple of guys sitting at a computer panel inside that van. Whereas a few years ago we had operators actually standing on every piece of equipment, which they still do on some other jobs now that they don't use high-tech stuff. Kick it open to some questions and answers now before we get into the computer part of it, look at your maintenance and try to answer any questions you might have about what would be expected of you as a Halliburton mechanic, anything of that nature. Any questions you might come up on the field in particular?
Is it slowed down after the oil boom?
Unfortunately, yeah. When I got out of school in '71, I was in the diesel club here. We took a trip to Morgan City, Louisiana, and it was sponsored by Halliburton. And at that time, I think they made some kind of offer like this. Everybody that's graduating, I don't remember how many in the group were graduating in the club, considerable number of us, down there, 50 or 60, well, somewhere around 50 of us. And they just about as hired everybody that came out of school at that point in time. If you got out of school and all they were ready to get a job, well, obviously it's not that way today anywhere. The economy's had a downturn, and Halliburton has seen that too. I think we're now just beginning to see an increase. Hopefully we'll start hiring again in the near future. Right now, Halliburton has had a hiring freeze on for the past 6 months, and rumors I hear they're going to lift that first of next month. Then it just depends on where there need mechanics and what the job opening. Some of our sister companies, like Brown and Root, Industrial Services Division, some of those companies didn't have a freeze or hiring slowdown, and they have still added mechanics while we've been kind of in a slump. Halliburton closed, consolidated a lot of locations. We're traveling longer distances now than what we did. They had a lot of smaller locations, and they consolidated those into creating larger locations, actually covering more territory now. Like I say, I worked in the field for them for about 15 years now, and just recently went to Duncan on this project. One thing I mentioned to the class this morning is picked a good way to start into a mechanic career. If you want to advance later on into management, shop foremen, things of this nature. The job that I hold now is called a technologist classification. They have mechanics, technicians, and technologists. And that's, the only thing after that would be the engineers. And I'm nowhere close to being an engineer. But if I hadn't had an associate degree from here, I wouldn't have been qualified to apply for this job. In other words, one of the requirements was to have an associate degree. It was just a great VOTEC school, but you get an associate degree with it. And a lot of companies look at that, Probably one of the things I mentioned this morning they look at more is when they come to interview or hire, probably more than grades, is did you show up for class every day? Because the main thing they're interested in when you get to the field, they're going to show up for work every day. And you don't have to be a super mechanic and know all the shortcuts and be able to flat rate a job and manage to get to we don't run by flat rate anything. It's strictly by the hour, and nobody stands really over your shoulder. You're on your own a lot, but they're looking for somebody to show up for work every day. You could be a little bit slower on the production end of it, and as long as you showed up for work every day and kept your nose clean. When I say that, of course, everybody has the drug program nowadays. We're all aware of that. The school is preached that. I didn't even mention that. Yeah, everybody's got a drug program that you have to pass now. But besides that, not showing up for work, I can't think of a whole lot of reasons that they ever run you off, other than just lack of work. The mechanic ended up probably laid off less than we have in other crews. Halliburton was notorious for working shorthanded in the shop anyhow. So when they go to cut, usually the shop's already working understaffed, so they really usually don't hit the shop that much.
We had a fleet of ships there, Halliburton.
I think we've got about 12 maybe.
Well, what all we required, mechanic, don't they have an on board
Yeah.
mechanic there or technician to run?
Yeah,
the
they
ship?
have a mechanic that rotates off there and assigned to that all the time. In fact, on the larger vessels, they have 2 mechanics. One of them strictly works on the vessel as far as the engines and power, the propellers and light plants and whatever else. Then you have a second mechanic that's actually a Halliburton mechanic, Halliburton service mechanic, and he will work on the downhole pumping equipment. In other words, the engines, transmissions, pumps, all the things that land-based Halliburton mechanic would do, except that these items are set down in the hold of a ship. So normally they'll have 2 mechanics on the larger boats.
So one of them is more of a certified scuba or on the
Well,
water side.
I'm not real familiar with what the mechanics that are actually assigned to the maintenance on the ship, the engines that actually drive the ship. We're talking about maybe the same engine with 2 different systems, same type of power plants, and they may they may help each other while they're out there. But on the ships, they'll have usually the larger they'll have 2, and one that I'm familiar with is the people that basically do the same thing on land, except that they install this stuff down on the ships. They'll also, on the offshore rigs, they don't have mechanics out there. They'll take land-based mechanics and if something go down offshore, get a helicopter, take them out there by boat, they'll fix whatever it is.
There's nobody standing, there's not a mechanic standing on the platform and all that.
When they're running fracks, yeah, they'll take a mechanic out there. Usually if they run a large frack job, that's where you saw all that equipment put together, they'll have a mechanic on location just as standby all the time when they're running frack in case something goes down. Now, on a rig, offshore rig, we'll have cement equipment that is actually put on that. They sign a contract for X number of years, and we put our equipment on that rig, and got the engines and the bulk equipment and all the things that the mechanics help maintain. And on that, then they just take somebody out. Like if they're going to do a cement job, they'll have an operator out there all the time. When they get to a certain depth, they've finished drilling, they need to run some cement or whatever it is. He's there all the time. That doesn't require a mechanic to be there all the time. So then if they need a mechanic, something goes down, they'll usually bring him in, flying in by helicopter. If they're doing a large frack job, and usually when frack jobs on offshore work is done off the boat, like that Skinny's fjord, and all the equipment is on board a vessel, ship, and they just tie up next to it and do the frack from the vessel. Because the rigs don't have, there's not enough room on a rig to put all that pumping.
How much do operators and mechanics make approximately?
Okay, starting wages, it's been so long since I've been at the starting wages. I topped out as a mechanic and I got laid off in '83 and I came back and wasn't quite at tops when I came back because there'd been one raise period in there. I would say, well, it's just going to be a guess. I'm going to say the starting wages, and it depends on what area of the country that you're going to work. California's a buck or two higher. This area around here, you're probably looking at, from Okmulgee, if you graduate from Okmulgee, you're probably going to start at a little bit higher wage. I would say probably around $8 an hour, something like that. And I'm just guessing. I could be $1 off. I don't think it's going to be any lower than that.
Whenever like team operators pull into a location, how much invoice make?
Okay, they're not on an hourly wage. They're on what they call we call it a BELO contract. I don't know what the first part of that means, but they're on a contract. They get paid so much, up to so many hours, and then after that many hours, then they go on a overtime schedule. But they're because they're on call. They might go out there and sit for a long period of time and never get out of their pickup. Waiting for they might be called out, and it might be they maybe think they're ready, to set casing, and all of a sudden they run into some hard drilling or something, and those guys can sit out there for hours waiting. So they went with a
So who's
contract.
paying for that?
Well, actually, eventually the rig is. pays.
Because they call them out there.
Yeah, it's figured into a job ticket. They'll charge them waiting time. But basically, that's how that works. And mechanics are on an hourly wage, are guaranteed, with Halliburton, are guaranteed 48 hours a week. Okay, when I say guaranteed, you gotta show up for 48.
Yeah.
Okay? In other words, if there's not any work, you know, if we're real slow, you might be a sweeping the floor or something, but they're gonna guarantee you that you have the opportunity to work for 48 hours. After 48 hours, after 40 hours, you're gonna go on overtime. So you're gonna automatically have 8 hours of overtime. That's the way it normally works. So then, after that, then weekends and holidays are time and a half. Some of that I don't really remember a lot of it. The wages in Alaska are a little higher. You go up there and they live in what really looks like a nice hotel now. They just finished a new facility up there. Everything's all enclosed. Every piece of equipment that they have in Alaska has it's all enclosed. You can't even see any of the pumps or the engines or anything standing outside. And the walls are about yay thick, and because it was extreme cold up there. And then everything, you don't even have to go outdoors to go into the shop. You go right from this hotel looking structure right into the shop. It's all brand new. I was up there last winter, and I think when I got off the airplane in Prudhoe Bay, it was 60 below. That's not including the big chill. It's a little chilly. And I worked in North Africa and Libya, and I've seen 120 easy. And when you drop a wrench in Libya and it disappears into the sand, if you could find it before it hit the sand, it'd probably be so hot you couldn't pick it up anyhow. It's not quite that bad. It's fun. We had a saying over there that never have so few done so much in so little. It took, give you an idea, over in the Middle East, just to get parts in, could take up to 6 months or a year just to get parts shipped in. Now that's by boat. If you air freight it in, it's probably looking at a couple of months. Just to when you even air freight the stuff in, by the time the order comes back to the States. And you just don't go down, the starter goes out, you don't run down to a local Napa dealer to pick up the starter and slap it on there or something of that nature. They try to keep stuff on hand, of course, but there are days over there that you spend twiddling your thumbs, sitting around. But it all evens out. You spend a lot of time, windshield time with Halliburton driving to and from locations. But when you get there, sometimes it's no-bows, and you know what? The job's done, and I have come back to the shop, and they have a job to catch the next morning. And I've stayed there all night long and rebuilt the pump or got an engine going or whatever it happened to be, and then maybe go home and get a couple hours sleep and go right back out. You're not going to keep that up day in and day out, obviously, but those things do happen. So if you're looking for an 8 to 5 job, anything in the oil field industry related, it's not going to happen. I enjoy it because I get out, I get see the country, I get to travel. I enjoy the responsibility. You feel good after you get the thing back online, it's running. This kind of thing.
Halliburton looked at any of your graduates last time?
I'll be honest with you, last trimester, I don't think so. Hopefully, like I say, hopefully, actually was frozen. It was just frozen. The hiring was on for Halliburton service now. Like I say again, they have done some hiring in some of the other areas of our sister company, Halliburton Services. I've noticed in my travels, and I've been to almost every location in Halliburton now in the United States, for one reason or another, all the way from Alaska to Florida, that a lot of the I've met a lot of older mechanics and shop owners that graduated from school. that's a real advantage you have coming from a school like this, as opposed to just strictly just a vortex. They still do the welding, the welding. Halliburton mechanics do a lot of welding. I know when I was transferred to the Middle East, to get into the country, a lot of the way the laws read over there, that, if they could go out and hire somebody locally to do this same job, they were supposed to go that way. But so they had me classified as a welder and as a mechanic, and I don't know, 2 or 3 things, just because they had to do that to get you into the country. But we do a lot of fabricating, a lot of welding, repairing things out on location. We'll have a welder on the truck, and we send a mechanic out, there'll be a welder on that truck in case something breaks. Usually it's a pass job just to get it in, get the thing going, and then bring it back in. Some of the locations have a full-time welder, but not very many. Most of that falls to the mechanics.
They supply tools?
Well, yes and no. They'll supply the larger tools, impact wrenches, special tools, torque wrenches. Pretty much what you're going to find in the job market in general. Your basic hand tools, they're going to expect you to provide, bring with you. If you go overseas, they supply everything. They don't expect you to carry, it's prohibitive to carry that much weight or travel a lot. They'll supply everything in the overseas environment. And to do on that. Most of the mechanics with Halliburton, after they've been there a few years, accumulate a pretty good set of tools. I know how expensive it is now to buy tools. I told the Snap-on dealer here a while back, but I said, man, these prices have just gone out of sight. He said, well, so are your wages. And I said, yeah, but not in proportion. The tools have gone up a lot farther than what the wages had in proportion. As a whole, that's what stuff. If you go into most shops you're going to go to work in, you have a good set of hand tools. The other guys that are there are going to help you as long as you don't make a habit of it and you get done with it, so you give it back to the same condition or most guys are pretty good about working like that. We hired a lot of mechanics that have a lot of tools. Have any problem there on that end of it? They don't expect you to have something across the board. Any other questions on the video? We'll take a break here in a minute, come back and we'll get into the computerized. Looking at Halliburton a couple of years ago, if they'd had somebody walked up to one of our managers and said, how much does it cost to operate a piece of Halliburton equipment for a year? They couldn't have told them. They didn't have a clue. During the boom, I guess they were making so much money they didn't care. They didn't care what you spent. They just write a check for it. Well, those days are long gone now. They're looking at the bottom line. So they initiated what we call computerized equipment maintenance program. We bought the program from a company. They call it Transportation Management Techniques. It was designed for an over-the-road trucking company, or it could be used for a commercial shop, either one. Halliburton has modified it for our use, and we call it CIMS, Computerized Equipment Maintenance System. And we record all the maintenance, everything that is charged to a piece of equipment, all the way from fuel to tires, we can record and track through this equipment maintenance system. And my job now is to go around and install these computers for Halliburton in our shops and train the shop foremen and mechanics to input the information to actually the main piece of information we put in, of course, is repair orders. So that's one of what we will be looking at. Just a few other things, and much of your time to cover. But that's basically what we're going to get into. Okay, well, let's take a little break. When you come back, you want to kind of move up the front. Most of you have had a basic computer, right? More or less, or some of you have, or you're going to, or most of our, I won't say most, I'll say all of our mechanics and shop foremen, up until the last year or so, most of them, they couldn't turn a computer on. I mean, they didn't know what the power switch was. So if you know anything about it, you knew more than what they knew when we first started in this thing. Now we've got a computer just about every, well, we do have in every location in the United States and Alaska, which this doesn't show. We've got a couple of locations up in Alaska. We finished implementing the computer system in the United States, getting ready to do Canada, and then we're going to do international. All of our computers are linked together. We've got a terminal like this at every shop. We're training the mechanics and the shop foremen to input the data. The data is collected at the central point in Arlington, where the mainframe is located, and then the computers can share information between different locations. Example of that would be if I have a piece of equipment and it started its life in Oklahoma City after the manufacturer in Duncan, they sent it to Oklahoma City. Maybe it stayed there for a couple of years, they transfer it to Colorado, we'll say. All of the maintenance records are transferred via the computer, and it just follows this piece of equipment around wherever it goes. Where before, all we had was a bunch of paper records somebody had stuck in a drawer somewhere, and half the time, the records didn't make it there with the equipment. So we had no idea of what the maintenance history on that piece of equipment was. It's pretty small, you can see it. What does this computerized system do for us? Well, equipment repair history. One of the main things, as I mentioned, you can bring up the repair history for any piece of equipment, pinpoint high costs of components, identify causes, compare fleet costs, spot potential problems. We can figure out where we're having our most breakdowns. We can compare these with other locations, whether it's a component failure like starters or alternators, something of that nature, pumps. Compare fleet costs. What they're talking about here is comparing like in a truck, like a computer built for an international, or an engine, one engine against another, Cummins versus they get better use out of the Cummins than they are the Caterpillar or something of this nature. And of course, it's going to spot repeated. It's going to show you any problem areas that are going to come up with the same problem, the same thing keeps breaking down all the time. Component history records. We can accurately log component history records for each piece of equipment, so we can analyze it. And that's the big thing they take all this information and store it in the mainframe in Arlington, and they go in and they write just one report after another that the managers look at. It's really us as mechanics, a lot of those reports we don't really care about. But the managers do. It's the bottom line, making money for the company. Repair orders, that's the biggest thing that we'll be putting into this maintenance system that our shop foremen and our mechanics put in are the repair orders. Preventive maintenance, this is something that is real big now. The Halliburton, they've always said they had a good preventive maintenance program, but I would probably take exception to that. I know Ryder Truck Company's been on a computer system for a long time. And Ryder Truck Company, I heard a presentation a guy gave one time. It says we do, I'm just going to throw a figure out here, 75% of all of our maintenance is preventive maintenance. And one of these days, we'd like to get to 100% preventive maintenance. So the only thing we ever do is preventive maintenance. In other words, with a computer system, they track the use of the equipment. Breakdowns can be tracked accurately. If they know how many hours, miles, however you're tracking this equipment, how much use you're getting out of it. And that way, they say this particular starter gives us X number of hours of use, X number of miles, whatever they're tracking it, and if we can bring that in and replace it before it actually goes down, then we don't have any breakdowns. That's preventive maintenance. Zero breakdowns. Of course, we're never gonna achieve that, but that would be a idealistic goal, and that's one thing that we're doing with the community. Diagnostics. I'll do a printout here and pass it around. It shows what we have set up in this computer as a diagnostic for say like an APM. This is also a pretty good deal for, before we went on the computer system, if we had a truck that started its life say in Oklahoma City and it went to the North Slope, they had no way of knowing if the preventive maintenance that had been pulled on that piece of equipment was the same in Oklahoma City as it was in Alaska. It had just pretty much been left up to the individual locations to take care of. And we found that, you know, one guy's doing one thing and one guy's doing something else. And now with the computer system, we feel like we're pretty much all on the same ballpark. We're doing pretty much the same as far as preventive maintenance goes in all of our different locations. Another thing that we track with the computer, I'll just show this before we get any further here, is our tire program. We got what the main, we're going to give it away, what the main cost of maintenance is in an over-the-road fleet of trucks? Tire. That's the number one maintenance item is tire. So we go in and we'll put a brand like this on our tires, and we'll track that tire from the minute it's put into the tire program, the minute we buy the tire, and then when it's installed on the truck, and many times it's recapped. You can track the whole life of the tire for an individual tire number and find out how much usage, how much wear we're getting, Firestone compared to a Michelin, et cetera, and this has been one of the big money savers. And we also track this in the computer, the tire program. So a lot of our locations, we have, probably wouldn't be a mechanic, we have most of your Halliburton locations, depending on the size of the location, the smaller locations, mechanics do a lot of preventive maintenance, and some of the larger ones, they might have somebody that does some of the preventive maintenance will be done by somebody back in the grease room, where, you know, that's all the guy does is change oil, grease, things like this. Some of the preventive maintenance items have to be performed by mechanics. But the people that do that will then take care of that tire program. Mechanics don't have to do that. Some more of the features for the CHEMS. We call this computerized equipment maintenance system. Vehicle life, cost cycle accounting, DOT record compliance. This is real important right here. And I don't know, they probably don't cover it much in school. When you get out in the field, you'll find out that DOT requires you to keep an active record of on file. They can walk in and look at that record at any point in time on an over-the-road vehicle. Even if you sell that truck, you have to maintain those records for at least, you have to keep them for 6 months. You have a lot of DOT things to keep. Talking about this is vehicle maintenance record transfers. This is where I've got a vehicle and I've got it in Oklahoma City. I sent it to Colorado, and via the computer I can transfer those records right up to Colorado. And say I had put this helps on our warranty too program, where we lost thousands of dollars that we hadn't realized on warranty work. Say I have a tractor out here, it's 2 or 3 years old, and I have to put a starter on it. Well, that starter has been warranted for a given period of time. Well, say I transfer that vehicle to another location. That starter might go out a week after it gets there. Here, a week ago, you just put one on here in Oklahoma. You got to Colorado, they might have to put another starter on. They had no idea that thing was under warranty. Now with the records that we've got in the computer, if we bring that vehicle up and bring up a system code, we're going to fill out a repair order and use these little books, we've got a system code in there that we use for starters. We get your system code. If you bring that vehicle number up and that system code, the computer will beep, 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 beep. This item is under warranty. If I was going to type in, I put another starter on, the computer will tell me, hey, whoa, wait a minute, you got a warranty coming on that item. Halliburton has lost thousands of dollars over the years. We never turned warranty claims in. Now they're starting to look at that. Standard industry coding, not getting into that. There's warranty on local parts and local parts management. There's a parts module in here along with the warranty that I talked about, that we have the ability to stock parts in this computer. We fill out the repair order. All we have to do is type in a part number and it brings up the cost of the item, fills out the rest of the repair order for us. If we have that already, it's got to be input in the computer. We're now in the process of designing a standardized parts list. And we saw that, all that equipment on that, we showed on the video, that's a pretty good list of parts. I don't know how long, I'm presently manually putting this into the computer. I may be doing that a year from now, right? I'm not getting too far on it. We're trying to standardize the parts list. And once that's put in, then all we have to do is type in the part number. Those guys, it'll give them the price. That is, these are things we stock and don't. A lot of stuff we buy local and rebel. PM scheduling. We're going to look at that a little bit later on here too. I can schedule my PMs. I can schedule a truck for a given PM that we have set up for a standard PM, an A, B, C, or D PM. Each one of these PMs, like an A PM, will do X number of things. A B PM would be more intensive, we check more things, and so on down the line. And also, I can bring in, say I want to change all the fluids in one of my gearboxes, transmission they're in, this kind of thing. I can code that into the computer. I can come in on Monday morning, I can print out a sheet, and it will tell me exactly what's due that week. You can write in, you can type in a projected time period that you want the computer to tell you. It will tell you exactly what's due PM-wise against that vehicle for that given period of time. Schedule work and when we get a PM. And that's why it's 20 after 4 PM becoming one of the major things. If they can, when they're out there pumping those $1 million jobs down the hole, and something goes down, it'd be a whole lot easier if they replaced it before it went down. We're not anywhere close to that. But that's one of the initial end results, which ties right in with the component failure information. Paper work, paperless work order. Well, yes and no. They said, well, it's going to take less paper. I'm not sure I believe that. I think if I buy stock in a paper company after they came out of the computer, I'd be a millionaire when this thing goes through paper. And now you can generate all these reports and on and on and on, but our mechanics still have to fill out what we call a work card. We give them this little book. We'll look at one of the work cards and we'll actually type in the repair order. But by using that little book, they fill out this work card, and then whoever's inputting the information uses a shop form to lead off the mechanic. We'll do the typing in. Some of the shops will be promoted. They teach all the mechanics to do the input. Direct and indirect labor comparisons is, I didn't get into that this morning when we were looking at this, but we also, as a Halliburton mechanic, you might spend 8 hours during the day working on a given piece of equipment, and then you might spend 2 hours sweeping the shop. Maybe when you got done, you might sweep the shop, or maybe you had to go over to the bulk plant, fix a valve over at the bulk plant or something like this. So this is labor that we can't directly charge to a vehicle, so they call that indirect labor. So ideally, if you work 12 hours, you've got someplace in the computer to account for those 12 hours. We don't pay, Halliburton doesn't pay by our mechanics for the time they put in the computer. This is strictly for tracking the cost against the vehicle, labor, this kind of thing. We're going. We're actually not paying, it's not at this time anyhow. So, that was one of our guys left kind of, they're gonna have an accurate record exactly what I'm doing, but we don't even look at it like that. We're not using the computer as a pay service. They're still just, they showed up for 12 hours, they get paid for 12 hours. However, it doesn't use a flat rate. Our guys don't really have to worry about that. Now, there may be some shops if you go to work in them that would pay, if you don't, you're getting paid by exactly a flat rate. Anybody have any questions? If they have any questions on this as I'm going along, speak up. This is kind of what I do on the blackboard earlier today. As I said, we have a computer in almost every location. What we do in every district shop in the United States now. We have one in, we've got engineering, which is over here in the right-hand corner. That is Duncan, Oklahoma. All of our information is stored in the mainframe in Arlington. The division managers can pull up reports at his terminal in his offices. Engineers and other authorized users, I don't know who those are down in the right-hand corner. But what we do in the district shop is on Mondays, we do what we call a download. So we suck information, which is usually put in by engineering, updates. We suck all that into our computer on Monday morning. It updates all of our software. Also, if we're transferring equipment from one location to another, we download vehicle transfers into here at the same time. If this was Brighton, I had one transfer out over to one city. I get my those records to show up on Monday morning. On Fridays, I transfer my repair orders via, this is all done by a satellite system. I transfer all my repair orders to the mainframe in Arlington. Well, there's a couple of reasons they do that. One reason is because if you didn't, the hard drive and the computer would be full before too long. Wouldn't have any more room to store information. So, and the other reason is so that they can pull that information off the mainframe and generate all these reports. Good typist? You guys want to volunteer to be a typist? Nobody volunteers. Want to type?
No.
You know what? You hunt the peck artist is all you have to pay. Have you ever tried? Come on up.
Very often do that. Very often do that.
Let me get this thing booted up here. I'll have you do my type here. So the way okay. Okay, need to, first thing to do, of course, I've already turned the power on this thing. You got to type in a code word. The guy that put this one in is Vetti, V-E-T-T-E. Must have been a... It's going to come up here. See where you got the little keys? Thanks. Okay, hit enter. Let's see if we got it. Yep, we got it. Yeah, we just replaced the monitor with this. So now the computer's finished booting up. It's going to come up to what we call a Halliburton menu. We created this menu, and basically all this is just a little batch file that we created. We've got, it's kind of hard to see from back there, I realize. We have a TMT, Transportation Management Techniques program up here. That's what we're going to go into. The rest of these are just different things that we've got set up in the computer that the guys have to use occasionally in the field. We go out and set this up in the field. We don't expect them to know any DOS. They don't, like I said, most of them have never turned a computer on before. So whatever you learn here, you're about 200% ahead of the people we normally train in the field. Number 2 is the formatted disk, and this is the backup for data, and this is to go into the mental systems and this next screen. So we're we're gonna take a number 1 and enter and go right into TMT. Okay. And if you read the bottom of this, as if you were reading a computer screen, you just press space to continue. This is all what we call menu driven. You just look at the screen. Okay, this says change date or time. We'll take it like it is. Just hit it in, keep on going. Okay, here's our main system menu. Now, one thing we didn't do before I got this turned on, I'll back up here and take this off here for just a minute. Mike, we're going to use this stuff here. Get those little red books. We're going to real quickly fill out we're going to enter a repair order. And this is, I'm going to go through this and I'll just write it up here on the blackboard. First thing we do on this is what the mechanic can keep in his toolbox, and then he turn this into the shop foreman, or he can take it to the computer himself and enter the information. The first one is, was this a completed job? And we either just X yes or no. The second box is repair order number. He won't have that because that's automatically generated by the computer. The third one is the vehicle number. Well, most of your Halliburton vehicles, we'll say this is a trailer. We'll say this is a frac unit. We've got a couple of V12s here, transmissions. We've got a couple of pumps back here on the back. So we've got a number that we call the company number that works for this whole unit. That's a 4-digit number usually. We'll say this is 4589. Okay, that encompasses this whole unit. And they assign these numbers to it. Okay, now, if I want to track the repair history on that vehicle, the way Halliburton's got it set up, they want to know how much money they spent on that engine, the right and left engine, or on the chassis. Okay? So now I've got it set up. I'm going to have a 4589. I'm going to have a L, an R, and a C for left, right, and chassis. Everybody with me so far? In other words, I'm just adding L's, R's, and C's at the end of those numbers. So I can split this thing up and I can track by engine hours. I can itemize, to each one. Also, these units have a little pony motor down here for an auxiliary engine. So I might have it split up 4 different ways. So that'd be the number I put in there. Would be my vehicle number. And the reason I kind of broke that down for you, I'm going to pass around an inventory sheet here that we'll print out, and you'll see those C's and A's and L's on there. Also, when we're inputting a repair order, it's going to ask us which one we want to put. Okay, repair class. If you look in the very front of the book under the little index, repair class is on page 4. Okay. So under repair class, is this scheduled, non-scheduled, or emergency? Well, the way we do it is Halliburton has decided that if it's not a preventive maintenance item, in other words, we didn't schedule it in as preventive maintenance, then it's going to be non-scheduled. The only ones we're calling scheduled are the PMs. Things we did were scheduled under PMs. Everything else, if it breaks down at some other time, then it's non-scheduled. Emergency, well, maybe they called me out in the middle of the night, I might throw an emergency in there. I had to go drive 200 miles down the road to fix a water leak on the truck out there so we can get back up. I'd use that one as an emergency. Normally, scheduled and non-scheduled is what we use. So we're gonna call this one repair class is going to be non-scheduled is 02, right? Okay. Well, all we have to know is just that that's a 02. That's all we put down on the form. Okay, the next thing is repair site. That's the next one down below. District shop, out of the yard, other district, outside vendor. District shop that we use on this one, we did it in the yard, the Halliburton location, that did 01. Okay, next thing is the meter reading. It could be either in hours off of the engine, could be miles off of the speedometer, it could be miles off of the hubometer on the trailer. We're going to say it's miles off of the hubometer on this. We're going to use the chassis here. We're going to say that we did a brake job on the chassis. So we're going to say we used the hubometer meter, got the mileage off this chassis. Okay, system code. If you look on page 5, system code start with 001 for an APM and go all the way through page 25, which is 9905. And then they started on electronic code, which I'm not going to talk about. I don't know anything about it. We put those in there for the electronic technicians so that they can put in their work orders too. I don't get involved. All right, so the system code on this would be, we're going to say we're going to do a brake job on this. Let's say we did let's say brakes, all wheels. Anybody see that, page 7? What is it? 1470, right. Okay. We got the guy who writes that in there. System code. Now, symptom code. We turn to the very back of the book. On page 25. And it says up there, actually it says system again, but if you look on page 43, it says symptom codes, and then it's telling you for what symptom code that you can use this. And then if you go to 45, you'll look at for all the system codes from 0100 through 99, you can use the ones underneath that. So we're going to say these brakes were, why did we do this? We're going to say 01, defective, damaged, or broken. We're going through this. I'm just trying to give you an overview of how this system works. I'm not trying to really train you to use this system, of course. Because you get to whatever company you go to work for, they're going to have their own type of system, probably something similar to this. And my guess is within the next 4 or 5 years, just about everybody in the industry is going to be doing something like this. It's just about being pretty well widely used. Okay, we're going to say 01 for symptom code. Now the next one is reason for repair, which is back. Why did I do this? Reason for repair is on page 2. And I did this because a driver, I found it on a driver's report, said he ran through the stop sign last night, ran over a little old lady in a car and brought his truck in and said the truck wouldn't stop. It's your turn to do something about it. So, driver's report, 04 is what I'm going to put in there. I'm going to put 04 for driver's report. I'm going to go back and pull this now on the parallel. Okay, here, comments, all I have to do is just do a brief description of what I did. Since we did brakes for all wheels, we'll just say R&R, all wheels, and complete brake job or something like that. Just when you get out in the industry, you'll learn that, on the repair order, they don't give you much room to write. And they don't even on the computer either. If it's a paper repair order, you don't have much room. And you'll find that you get to where you can abbreviate things pretty quickly. So we'll write our comments in there. Let's see, the next one is, do we charge any parts to it? And we'll say yes. And then we would drop down here and we list our parts. We'll just make up some parts when we get over here. This on the computer screen. So we're ready to go. We're ready to go put a part in. But before we can do that, we gotta find a good vehicle number. This one I made up here is a good number. It's not actually in the computer. So I'll tell you what we'll do. We're gonna print out a vehicle inventory sheet first. I realize that I can't focus that any better really than what it is. Just have to do that. It's real sharp on the screen when we're using the screen to put it up here. It leaves a little bit to be desired. This, I write a cheat sheet out for the guys when I go install these computers, and then pretty well, after you've gone through this program a few times, you realize where these things are. But we're going to go into Vehicle Performance System number 3. And you don't even have to hit enter after these. There's 3, and it takes us to the next, just one step deeper into this program. Now we want to do is a vehicle inventory report number 7. We're going to look at a vehicle inventory for a given shop. Every Halliburton shop we install a computer at has a different shop location. And I can generate my reports by unit numbers. If I just give a number of unit numbers by the number, I can do it by a fleet. I can do like international versus Peterbilt, something like that. I can go by company number, or I can go by domicile shop. I'm going to go by domicile shop. When I was learning the system, I said, what the heck does domicile mean? It means home. I didn't know that. I didn't teach me that at home. I had no idea. So we're going to go by number 4, domicile shop. That's the home shop. Okay, now we're going to type in the shop number. This one happens to be 000300. Okay, we have 2 ways of generating this inventory report. We can either view it on the screen now, or we can print it out. We're going to print it. Just kind of print it. Printer's up close. Yeah, 2. Okay, now it says at the bottom, it says make sure printer's at the top of the page. It is. Now all you have to do is hit space when ready. And that's what it's printing out this inventory report. While it's doing that, what's the let's see, go down on that report towards the bottom until you find a unit number that has numbers and letters behind it. You might have to fold that thing out.
75711 VA.
That'll do. What is it?
57.
75711
VA.
ZA. Okay. Just kind of ignore that Z. It doesn't mean anything. Somebody remember what we read out of that book, because I just remembered. The Z was Halliburton, when they got ready to enter all their inventory, they started duplicating numbers, and so then they started using letters. That's all the Z is. But these A's would be like the auxiliary. And it probably has, what's it have under that? A has the same number again?
Right, there's a C.
Right, chassis.
There's a F.
Front, probably, for front engine, and so on and so forth. We got a C though, right?
Right.
So we got a 75511 ZC on there.
That works.
Okay, we'll use that. Okay, so now we've generated our inventory. Pass another one of these around. You go ahead and pass that around. Let's take a quick look at it when we get through, and I'll have another one in a minute. I can't put anything up here until we quit printing. Do they stock a lot?
Yeah. Or they usually have to order them.
No, we actually stock a in Duncan, 51,000 truck parts. I think is what they told me last week. The only reason I know that is because I'm working on this parts module right now. That's just the truck parts. 51,000 different. Yeah, we have they do. We stock reconditioned parts, but mostly for what, like what you'd be working on, it's going to be new parts. And a lot of that, like if I'm working as a mechanic in Brighton, Colorado, I'd probably get that from a local vendor rather than order from Albert. If it was a part that I could get from a local vendor, like a Cummins part, Caterpillar part, or something like that, I could order it through Duncan. They may or may not have that in stock in Duncan, but it would take me through company truck or mail. It would take me a while to get it. If I'm in Denver, Colorado, they need that truck in the morning. I'm going down to my local Cummins dealer to pick up that part. One reason they stock so many parts in Duncan is because if I'm working over in the Middle East, I probably can't run down to my local Cummins dealer and buy parts readily. So Duncan stocks a lot of parts, and people go over there and they'll try to project how many parts they might need for a given piece of equipment and try to have those on hand. And we'll order those directly through Duncan because the availability overseas may be slim and none. More often than not, yeah.
Halliburton builds their own trucks.
Yeah.
Do they manufacture their own parts? A lot of them, or?
Right, as soon as it finishes printing, I'll answer that. Now you can just follow the bottom of that screen, and you can F2 for prior menu up here. And then probably F10 to go back to the main menu. Now another F2 for prior menu. And then now you can read it. It's kind of on the screen, it's hard to see. F10 will take you all the way back to the main menu. Here's another one of these. So anyway, we've got our good truck now. Actually, go put this in the computer. And we've picked out these things that we want to charge against this. So I'm going up into number 1 now, shop management system. That's where my repair orders are. Okay, number 1 says repair order activity. Now let's just go right on in and stick us some repair orders. Number 1. Now here we've got 2 types of repair orders. We've got a batch repair order, and we've got an open repair order. Batch repair order is what we're going to use today, is number 9. An open repair order would be one that I brought a piece of equipment in. It's going to be sitting in my shop for a week, 2 weeks, a month sometime. Maybe I'm going to do a complete rebuild on this piece of equipment, and I can continually add parts and labor to this thing as I go along. On these batch repair orders, once I go in and make out the batch repair order, I back out of this program and I can't go back in. He asked the question earlier, does Halliburton build a lot of their own parts? Yes. On all those pumps and everything that we manufacture, of course we build. That's the only place you can get parts for those things. Now, as far as we stock Cummins engine parts, we stock a lot of other things because people will order them from the overseas market. And they can't get them over there a lot of times. Might be one reason we stock that at Duncan. Normally, as I said before, if you're ordering a part for a Cummins or something, you just run down to your local Cummins dealer, and he'll bring it out and have it an hour and a half or so and be back working again. We build those complete units in Duncan. We buy engines from Caterpillar, we buy engines from Cummins, Detroit, all the big manufacturers. They actually build the frames in Davis, Oklahoma. Those were then taken to Duncan, put on an assembly line, and the assembly line we add all the pieces of equipment that they're actually manufactured in Duncan, which are the pumps, things of that nature, and a lot of the things related to the pumps, which would be iron and stuff that they use to pump the different fluids and cement down. They also build their own vessels as far as like bulk cement tanks and things. They do build their own cement trucks and cables. Basically, that's the way it works. You buy those components, engines, transmissions, set them on. We build drive shafts there because we have to have, different drive shafts have to be built to specific lengths to drive each pump. So we build our own drive shafts. They've got it showed a little bit of the machine shop there. I extended an invitation to the school anytime they want to bring like a diesel club or a group of students over. I'm more than happy to give tours over there. Or if you're over there in any reason in the area in Duncan, all you have to do is just give me a call on the phone. Let me know a few minutes ahead of time. We can probably arrange a tour. A day ahead of time would be great. But if you happen to be in town, maybe let me know and I can. Within a few minutes, probably arrange a tour if I'm there. And if I'm not, maybe somebody else can. We give tours of the facility all the time. It's pretty much, you come by, we'll try to get you a tour of the facility. And they have a huge machine shop. They do all, they have one building, they do nothing but painting. They have their own paint, dip, and spray procedures.
Where do they get your steel from?
I'm not real sure where they do buy their steel. I know they stock it out back. They have a huge area in the back of the plant where they stock raw material. But where they actually buy it from, I'm not real sure. I couldn't answer that question. I really don't know. They were even into building rail car couplers. Such a diversified thing. Other than we used to build some rail car pieces there at that plant too. It's a huge manufacturing facility. It's just, if you just want to see how a manufacturing facility works, let alone, the engine and that part of it, it's worth the trip. Well, they've talked about that at different times because when the industry was slow, let's go in and the first time they had a downturn in the industry, they actually didn't do a lot of work for outside companies, because in the machine shop, you don't have to manufacture for just yourself. You could manufacture for another company and then do work for that. And that has been discussed. And they did it at one time. They're not doing it right now. They may get back into it. So they actually build things for other I'm not sure how they move on this, but it's such a large facility and they have such a large investment in all that machine shop that a lot of it right now is actually with a downturn in the oil industry and they don't have X amount of orders per year for vehicles to be built on that assembly line, and of course that makes idle time for employees or machines there that could actually be producing. So maybe someday they'll get back into that. I think they're looking at it. Okay, so we're going to go into number 9, batch repair order entry. Okay, we don't use minor repair order at all. We just use a batch order entry, just do the ones. Anybody has any questions on this? We're going along.
So is this paper like every piece of equipment Halliburton owns?
That's every piece of equipment that's located in Brighton, Colorado.
That's just in Colorado.
That's just in one location in Colorado.
So when this system is done, are you going to be able to, if you get a piece of equipment from God knows where, you're going to be able to type its number in and show everything's been done to it?
Right.
Is that what you're trying to do?
Right. Exactly. Now, I can't do that from this terminal. I could do that from, if this was my terminal at my office in Duncan, yeah, I could do that. Because I can access the mainframe. Remember I said we take all this information out that we put in all week long on Fridays, and it stays in this computer in an abbreviated form. The detailed repair order that we're getting ready to make out will no longer be in there as a detailed repair order. We can go in different areas like repair order history and look up that repair order number and the system codes and who did the work and a lot of things we'll look at. But I'd have to go to the mainframe to look up that repair order detail. And And once the system is online, I can already do that for every piece of equipment in the United States. I can't do it for Canada or overseas yet, but that's, in the next year or so, we'll be able to do that. Yeah. And so I can pull up anything I want to for every piece of equipment in the United States. My desk done. The individual shops can do it to a certain extent. They jump over and log on to our, what we call log on to our mainframe, and through the satellite, and they can also put in some of that information. Okay. Let's keep on going. We got a big choice here, number 1. Okay, repair order number. If we just hit enter here, the computer will generate the repair order number for us. Okay, we got that. It defaults to today's date, so we'll just let it default to today's date. We'll say we're doing this repair order today, so all we have to do is hit enter here. And it gives us 83692. Is this a company unit? Yes. Just hit enter. Okay, that company number that we have, we said that was 75711Z. Don't type the A on the end, just 7511Z. Okay, we'll pick up the A on the second. This is called the header screen. We'll pick up the A on the second screen. In fact, when we go to the second screen, we'll probably bring up the A, and we'll have to jump over and change it. So, is this a potential warranty claim? No. So, just hit enter and keep on going. The name's already in there. These are hard to read up there, I realize. Shop number, type in 000300. This is the shop that the door was done. Is this a priority item? No, we're just going past that. We really don't use that. Okay, what do we say for repair class? We went into what, can you remember? Unscheduled, which was what? I believe it was 02, wasn't it? 02, okay. 02 and then. Okay, like that. How about repair site? Yeah, district shop, which was 01. 01 and okay, that's all we're using. Like I say, this was designed for an over-the-road trucking company or commercial shop. We've changed it for our needs, so we don't use this driver report down here. We don't use those 3 blocks. So just hit enter 3 times. Get past those. Now it asks us a question at the bottom. It says, do you wish to make any changes? Nah, we're good. We can make any mistakes. We have to answer the end though. Okay. So now, whoop, went right past the one above. See if I can get us back up. Just hit enter again. We'll go through it real quick. Enter. It's just like we didn't lose anything here. It's just like we just wasted a piece of paper. Big deal. We just enter. Yeah, it should just enter right on. It'll take you clear down the bottom. I had to put the company number in the end, which was 75711Z. There you go. Not bad. Okay. That should be still there.
Hit the up arrow. The up arrow.
Okay, one more time. No problem. Hey, he's doing good. A lot of these guys, I go out and they'll sit there and go, they just look at the keyboard. You know, they don't make a move. They just look at the keyboard until you tell them, in, 1. You know, these poor guys, they don't know a computer from yesterday. 75711Z. And just hit one more enter, and then no, letter N. Now, right there. Okay, now if you could read that, it says 75711ZA is up there. I didn't hardly make it out. But we don't want to charge it to the auxiliary engine. We want to charge it to the chassis. So you take the right arrow key, right on, and come over till you hit A. Okay, now it's letter C. Bingo, there we go. Okay, the meter date. you can put in any meter past the one that shows on the screen. The last time that a meter was updated, which is when we ever either updated the mileage or we entered the repair order, meter was 7596 on 6/12/92. Well, we could backdate this, but we would have had to backdate the repair order. They won't let you enter a smaller number unless you backdate the repair order. The computer won't let you make a mistake, is what I'm trying to tell you. Okay, so here, I'll tell you what let's do. Let's enter 17596 and see what it tells us. Enter. It took it. I thought we just had 7596. Normally, and I don't know why it didn't do it that time. Normally it will beep us and say, 15% greater, you know, and it says, are you sure? Ask you a bunch of, like, you know what you're doing. I don't know what, it didn't do it that time for some reason. Blew my little thing there, okay. System code, what we say for system code? Brakes. Look under brakes, and I think the very bottom one.
13.7.
Okay, type in 13 seconds there. Okay. There. Okay. Well, what about symptom code? What would we put in? Defective, damage, or broken in the back was
01.
01. Yeah. Very good. The reason for repair was, we got that from the driver's report, which I think was 04, right? Yeah. Okay, we'll do an 04 here. We don't use that, we'll just hit enter and go by it. That's for a flat brake. Now just type in a comment here like R&R rear, R&R at all brakes, something like that nature. Just whatever you feel like. Your girlfriend's phone number.
Free out 45. Ready to next day.
Rear, R&R all brakes. Replace and replace or something. Just anything. See how that's
Yeah.
okay, we hit enter there. And it gives us another line. If we want to type in more, we don't, so we enter again. It displays R&R all brakes and replace, okay? Now it says, do you wish to make any changes to this section? We'll say, nah, we're good. We don't want to make any changes. We'll hit the end for no. Okay, now it's recording that first section. Now it's jumped out here to go on charge parts. And we'll hit enter. I will say, you already hit enter, got past yes. Normally we did enter for yes, and for no. We said no, we jump over charge label first. Now we're already down to parts. So it says, we're going to enter our parts. Remember before I may have not mentioned it. I think I did. We have to, if we're going to pull these parts automatically from the computer, they have to enter that parts module in here. There aren't any in this one. So we're going to use V for vendor. So it says use either S, V, or N for non-stock. So we're going to hit a V and enter. And it's vendor. Now just make up a number real quick, type it in there. Let's say this is a big part. It's not going to do it. Whatever. Okay, description. Type in brake drum. Okay, enter. And it refers back to the same part as the part system code, refer back to our system code that we're working on. And enter there, we accept that. Credit. Well, the reason they got credit stuck in there is I'm not too bright. A minute ago, I went through here and added $150, and it was supposed to be put against a different truck. And now I can come back and use that same truck number and say credit, and I can take that off and I can straighten my books out. But we didn't make mistakes, so just say no. Everybody follow me on that? We're going through this pretty quick. Quantity, we'll say we got 5 of them. Add $50 a piece. 5. So it's going to multiply whatever we put in quantity by the amount down here. That. That's about how much a brake drum. $50 is how much one of those big brake drums cost. I bet you thought they were a lot more than that. Huh? I mean, you can't hardly buy one for a car for $50. Big trucks, $50 a lift all day long. Now they come out of Mexico. That makes a difference. I couldn't believe it when I started replacing $50. Wow. Okay, now, is this a PM part? No, PM part will do like filters and things like this, so we'll just hit enter here for no. And here I would type in a vendor number if I have it. Anytime Halliburton likes to check with a vendor, they have a vendor number. Normally I can type that vendor in, I can cross-reference that if I ever want to know, go back and find out who I brought that brake drum from. All I have to do is put in that vendor number, and I can get his name, address, and the whole 9 yards. We'll just hit enter and go by this one. Same on PO number and invoice number. Okay, now it's going to jump back up to the top and say you want to charge for the parts. We're going to say in for no. Now it's going to jump over to labor. I fouled up this one and I did here too. I forgot to get a good mechanic number. So here, it's not going to let us do this. We'll go ahead and hit enter. And when I get down here to about here, I'm going to have to stop because I thought my number was still in this break computer. It's not. They deleted it. I have to talk. Hit enter again. S for shop. Yeah, now as far as I can get, because if I type in my number, 54710, it says you don't exist anymore. Mechanic's not mechanic's database. So it tells you, meh. I was in there, I don't know why they took me out. I've been gone for a year and a half. Anyway, so I would enter the mechanic ID, work accomplished. The labor system would come up as the same as the system code we've already entered. The time, and it's going to figure the cost automatically, the date, and that's about it on this. That's how we enter a repair order. Now, if you'll hit an F1 there, get out of here, and F1 again, one more time. Now it jumps back up to that repair order, that same unit number. I could go back down through there. I did a brake job, maybe I did the engine tune-up. I can go back and charge that same way as many items, things as I want to under a different system code of that vehicle. And then I can handle all that on one repair order. Or I can back out of here and F order one more time, and I can start a brand new repair order and start all over. Let's go F2 out of there. F2 again. And now we can F10 all the way back to the main menu. And at any given time, the shop foreman can go in and pull up that repair order number and look at the what he's got in the computer at this time by doing the hit one, one repair order activity. It's already saved. It's already saved there. Yeah, one again. Okay, do it two. Require repair order activity. Okay, do a one. Work in progress. Well, man, I forgot that repair order number. That's all right. Do a one in. Now, I don't remember the repair order number. Do you? Just hit enter. Bring them all up. How do you know which one I want? How do I know? I can tell by the date. I can tell by the system code. 111. Probably the last 1110. No, you get space for the next page. There it is. 111114. Those are not updated. Wasn't that it? 75711ZC. Okay. Go F1 out of there. F2, F10. Okay, back to the main system menu. That is the repair orders that are currently active in this computer. Now on Fridays we do this strip and print procedure, and we strip them out and send all that detailed information. We could go in and look at in any one of those that's still on that screen. We could actually look at that detailed repair order, look at the parts, the comments, whatever we put in. But after the Friday thing, then we could go into one again here. And we could go into, right here is one of these. Inquire recent repair history by vehicle. Go into that. Got a big choice here. Okay, vehicle number. I can go and look up all the repair orders that have been put against that computer since it started, put against that vehicle, since its first day in the computer. 75711Z. It's probably going to go ahead and speak. Go ahead and put 75711Z. Let's say ZC will do the chassis. What do they charge to get the chassis? I think you got 2 Z's up there. Hit enter and see what it says. Yeah, wrong number. Try again. 75711. ZC. It won't hardly let you make a mistake. Okay, it says, what year period do you want to see? For what year? What period of time do you want to see the repair orders? I want to see them all. There's actually an L up here, I think. You can't see it. Hit enter. It should bring them all up. Let's look at it now. Life today. And the first repair order that they put in against that vehicle was done on, well, I think it's gone from the last one. It is. It shows the last one. It doesn't show the one we did because we haven't done an update yet, so this doesn't show on the screen. But this says 682.92, repair order number. There was the meter, the cost. I think you have 0 parts cost. 0 parts cost, labor for $5. Well, that was a biggie, wasn't it? 2 hours?
Was this?
Oh, that's time. I'm sorry. 5 hours. Excuse me. 5 hours. No, it's not either. That's cost. I don't know how they. That's nah. I'm not buying that. I'm gonna have to look at that one when I get back to the office and see what's going on here. I don't understand this. This is probably a normal thing. I got labor cost of 322 at 14 hours. I don't know how they came up with 5 because I think they've got the rate in the computer's like $32 an hour is what they've got set in here. So that should have been more than that. I don't know how that came up that way. Got a glitch there somewhere. It shows the system code. You can go in your book and look up the system code and see what that was. 1722. What was that? For 2 hours and $5. What's 1722?
Tires replaced.
Well, they must not pay their tire repairman very much. Well, you know what? I bet that was put in. It could be $5 too. The way it could be $5 is because that was put in by an outside vendor. Halliburton mechanics normally don't do their own tire repair work. An outside vendor did that, and he may have only charged $5 to switch out a tire. In other words, we have a set of tires, a rack full of tires out here, and we'll have an outside vendor come in and just actually do the work. So that could be right. They pull the tire off the tire rack. Yeah. Well, no, just to switch it out, just to take it out of the tire rack and put it on the truck. Take the bad tire off and stick the other tire on. $5. The guy's not making much an hour, is he? I don't want to be a tire repairman, but no, for sure. Okay. Anyway, we can go back in and look up the if you hit display more repair history, hit Y for yes. We can. There may be several pages of this. Go ahead and hit Y again. We'll see what. Keep on hitting Y until we get to the last. No, that was it. That was the last page. We had 3 pages of repair orders there. The first one was 91. We could print it out, but this isn't preset. So just hit F1, 2 or something to get out of there. If all else fails, what are you going to do in a computer when it blocks up? Well, that's close, but not. Yeah. Some of our people do. Yes, Control Alt and delete. One, two. Hold those 2 down. Hit and tap to delete.